Hello, this is question 4 on your June 2022 Edexcel paper, a statistics paper. You have a dentist that knows from past records that 20% of the customers arrive late for their appointment, and a new manager believes that there has been a change in the proportion of customers. A random sample of 50 of the dentist's customers is taken, and we have to write a null hypothesis and an alternative hypothesis corresponding to the manager's belief. So is this there are in this paper there are two hypothesis testing questions, this one and question 6, which is correlation. You are testing correlation, so look how important hypothesis testing is. So I'm going to write my hypothesis for the first one. H0 is always with the equal, and they say a null hypothesis corresponding to no change in the proportion of customers. So we are going to say that the proportion of customers that arrive late is still 0.1, yeah, because they say is 10%. And the alternative hypothesis corresponding to the manager's belief that there is a change, yeah. So P is different, and they say it's a change. There is a change. They don't say is the proportion is greater or smaller. So it says there has been a change in the proportion. We don't know if it's more customers arriving late or less. So this is part A. Then part B is using 5% significant level. Find the critical region for a two-tailed test of the null hypothesis in A. And you should state the probability of rejection in each tail, which should be less than 0.025. So this is like quite guided question, because they could just easily tell you that just do a hypothesis testing, give you the level of significance, and then do the rest, but they are like giving you the steps, yeah. So the first is writing the hypothesis, and now we find the critical region, and then we will decide at the end. So critical region, if I have a 5% of significant level or level of significance, you know it's going to be split in two. So I'm going to have, when this is different, I have two critical regions. So my critical regions is composed of two set of values. So I will have one left tail where I have x smaller or equal than a certain value must be smaller than half of the significant levels, so 2.5% or 0.025. And my other part of the critical region is when I have great value, big value, and again this probability is going to be smaller than 0.025. You know that we are going to accept H0 even if we don't believe is true, so we can use the tables or the calculator. So we are going to decide that this probability is really 0.1, and we are testing 50 customers. So n is going to be 50, and we are going to see if they are late or not, and our probability, if this is true, is 0.1. Yeah. To find the critical region, I think if you have the values on the tables, it's just quicker than with the calculator. So in this case, n is 50 and p is 0.1 is on the table. So let me show you the tables. This is the binomial tables in your formula booklet. You have n 50 and probability 0.1. So it's on the tables. This is the largest value that you have in the tables. So you see 40, 25, 30, they are very round values, and then you don't have any more after the 50. So we are talking about this column here. We are going to use this column here for P 0.1. And the first thing we are going to look is for value A, the first one, that the probability is smaller than 0.025. So if we check our values, the first one that is smaller than 0.025 is really this one. This is above, yeah? So my critical value is going to be this one, x0. So here, A is 0. So this part of the critical region is going to be x smaller or equal than 0, but it cannot be smaller than, because we are talking about number of success, so the smallest can be 0. So this is my first branch, if you want to think like that, of my critical region. And now here I don't have this in the table, because the table is giving me probabilities of x being smaller or equal than something, the same that with the calculator. So we have to prepare this question somehow. And remember, when we have a binomial distribution and we find the probability of x being greater or equal than b is the same as having 1 minus probability of x being smaller or equal than 1 less. That must be smaller than 0.025. If we reorganize this, we have probability of x being smaller or equal than b minus 1, greater than 1 minus 0.025, which is 0.975. And now I can go to the table because I have the smaller or equal. So I'm looking for the first value that is greater than 0.975. So the first value that is greater than 0.975 is this one, right? So this is my first value, which is 9. That means that this is going to be 9, and b, because I'm looking for b, not for b minus 1, is going to be 10. Yeah, so my critical region, this side of the critical region, is x greater or equal than b. So greater or equal than 10. So this together with this is my critical region. Yeah, I'm going to, so this is the important bit. My critical region is x equals 0 or x greater or equal than 10. Well, that's a disaster box. So I'm going to reject h0 if the observed value is greater or equal than 10 or 0, because if this is true and my probability of being late is 10% of 0.1 and I have 50 customers, I expect that 10% of them will be late, so something like 5, around 5. And what this is telling me is what is too far from 5 to believe that this is true. So, and these are the numbers. So if I get 4 customers late, it still will be okay. Still, I can assume that this is true. If I get less and less and less and I get 0, that means I am too far from 5 and this is not going to be true. Or if I get 10 or more being late when I expect 5, again, I will have to say that this is not true, or I don't think it's true. Yeah, so this is the idea. Then you should state the probability of rejection in each tail, which should be less than 0.05. So this probability here that we check on the table was smaller than 0.025 and was actually 0.0052. So we are going to write that probability of x being 0 is 0.0052. So this is the probability of this first section of the critical region, and the probability of x being greater or equal than 10 is 1 minus, so 1 minus this probability here. So 1 minus 9755, which is, I think I'm going to do in the next page here. And the probability of x being greater or equal than 10 is 1 minus probability of x being smaller than 9, which is 1 minus the value that we have here, so 0.9755, which is 0.0245. And both of them are smaller than the 0.025 that they say. This one just, but they are both smaller. And they say, what else? So this is this part, and then find the actual significant level or level of significance of the test based on your critical region from part B. So remember, this is like the target for our significant level, 5%, but these probabilities are going to be smaller than, but they are not going to be exactly 0.025. So the actual significant level is this together with this. So, and it's going to be smaller than 5%, but it's not going to be 5%. So we have 0.0052. We are just adding those probabilities, 0.0245 which is 0.0297, or if you want, you can write this as a percentage, because usually level of significance is given as percentage. Yeah. And what else? The manager observes that 15 out of the 50 customers arrive late for their appointment. And with reference to part B, comment on the manager's belief. So 15 is in our critical region. Is too much or too many clients arriving late. We say if we get more than 10, we are going to say that this is not really 10%. More than 10% are late. And this is the case. Yeah. So we have to comment something like 15 is in the critical region. I'm going to just write CR. So we have to reject H0. And if I reject H0, remember I accept H1. Yeah, there is enough evidence to support manager's belief. Yeah, and that's it. That's your questions. We could do this question without critical regions. So remember, we can find the probability of x being smaller or equal than 15 and see if that's smaller than half of the significant level, or greater. In this case is greater because we are in the right hand side of the critical region. But they ask us first to find the critical region, so we are going to use them to decide. Yeah, and that's all with this exam question.